So beta, this is what we had seen in the last lecture. We had seen how to plot and draw these position lines on the chart. We found out the compass error. So one of the questions was based on magnetic compass. They had given us the variation and deviation. We found out the compass error, found out the true bearing and plotted on the chart. Second example was using a gyro bearing. The gyro error was given to us. So we found out the true bearing and plotted it on the chart. This was the last what we did. So now the next method after this is transit bearing. So let's proceed on to transit bearing.
PL by transit bearing. Two lights or two conspicuous objects are said to be in transit when both are in straight line as viewed from the ship or from the observer. That is, the bearing of both the objects is the same to the observer. When in transit, the ship has to be on a straight line passing through those two conspicuous points or the objects. As there is one and only one straight line that can be drawn through 2 points on a plane surface, the line joining the two objects extended in the direction of the ship provides a PL to the observer. Transit bearings also provide a convenient opportunity to obtain the compass error.
Beta, any doubt up to here in this?
No, sir.
Okay, great.
Let us understand the transit bearing and its use for getting the compass error through a simple example. At 2000 hours, vessel observes Bellina-Coty light and Minehead light to be in transit. When in transit, bearing was observed to be 015 degrees gyro and 018 degrees compass. Draw 2000 hours PL. Obtain the error of the gyro compass. Obtain error of the standard compass or the compass error. If variation is 3 degrees west, find deviation for the ship's head. First, let us identify the Bellina-Coty light and the Minehead light on the chart. On the chart, this one is Minehead light and this one is Bellina-Coty light. Now we draw the PL by transit bearing. That means we join these two landmarks and extend them on the side on which the ship is likely to be, and that becomes the PL. Now you can see on this, these two have been joined and extended on this side where the ship is likely to be, and this becomes 2000 hour PL by transit bearing. Now we use our parallel ruler, put it on this line and read off the bearing of Minehead and Bellina-Coty, which of course would be same from the compass rule. In this case, we find that the true bearing of Minehead or Bellina-Coty, which is same, is 013 degrees true as read from the chart. The gyro bearing is given to be 015 degrees gyro. Obviously, the gyro error would be 2 degrees as the difference is 2 degrees. To determine whether it's high or low, we can see the gyro reading is high. So therefore, the error will be 2 degrees high. Now, true bearing, 013 degrees true. Compass bearing given in the question is 018 degrees compass. The compass error shall be the difference of the two, that is 5 degrees, and it shall be west. Why? Because compass best, error west. Compass error is 5 degrees west. Variation is 3 degrees east, given in the question. Therefore, deviation for the ship's head becomes 8 degrees west.
So beta, any doubt up to here, beta?
No, sir.
Okay, great. So this is the concept of transit bearing. It provides us an excellent opportunity to get the compass error. In fact, the easiest method, easiest way to get your compass error if you have the chance to get a transit bearing. So let's proceed ahead now.
Because it is the algebraic sum of variation and deviation, which is the compass error. Next is PL by opposite or reciprocal bearings. Two lights or conspicuous objects are said to be on opposite bearing or reciprocal bearing when their bearings differ exactly by 180 degrees. When on opposite bearings, the ship must be on the straight line segment joining the 2 points or the objects. There is one and only one straight line segment that can be drawn through 2 points on a plane surface. The segment joining the two objects or the points provides the position line. Unlike other PLs, this PL has a definite length. The segment is only between, or the PL length is only between the two conspicuous points. This PL cannot be indefinitely extended like the other ones. Opposite bearings also provide a convenient opportunity to obtain the compass error.
Anything not clear up to here, beta?
No, sir.
Okay, all right.
सर
Let's see the.
सर ये
बोलो beta.
सर ये प्लीज बताएंगे सर ये दोबारा टू लाइट्स
The first one, beta.
ये सर जनरली बताओ सर ये थोड़ा समझ में नहीं आया Two light.
Point number one you are asking, na?
ठीक है सर हाँ जी
Okay, it says two lights or two conspicuous objects are said to be on opposite or reciprocal bearings when their bearings differ by exactly 180.
ओके
Okay, so looking from the shape, if you see two objects reciprocally opposite to each other, one is on a northerly bearing, the other object is on a southerly bearing, this is what we call as a reciprocal bearing or opposite bearing.
ठीक है सर
Okay, beta?
यस सर सर एक मिनट जरा रीड करने दो बस
Okay, beta, you can.
ठीक है सर you can go ahead.
Okay, now let us see this concept on the chart. Let us have a question for the opposite bearings and we'll plot it on the chart.
Let us understand this PL and its use for getting the compass error through a small example. At 2000 hours, vessel observes hook head light and conning baked light vessel to be on opposite bearings.
Beta, as I told you earlier, all these examples which you are seeing, they are based on chart 5048. So it is one of the charts which is used for the MMD exams. So all these questions which you see are based on 5048. You can actually identify these objects there and you can do these questions.
At the same instant, hook head light bore 293 degrees gyro and 296 degrees compass. Draw 2000 hours PL. Obtain the error of the gyro compass. Obtain the error of the standard compass. If the variation is 3 degrees west, find the deviation for the ship's head at that time. Like earlier cases, let's first identify the two landmarks, hook head light and the conning baked light vessel. So on the chart, you can see this one is hook head light and this one is conning baked light vessel. We can now draw the 2000 RPL by joining these 2 points. You can see this blue segment here, joining these 2 points, is the 2000 RPL. If the vessel is anywhere on this PL, the bearing of hook head and conning wing would be separated by exactly 180 degrees. Now, read off the true bearing of hook head light. You transfer this line to the compass rose and read off the true bearing in the direction of hook head from the chart. True bearing of the hook head light from the chart is 296 degrees true. Gyro bearing of hook head given in the question is 293 degrees gyro. These two values give us the gyro error as 3 degrees low. True bearing of hook head light is 296 degrees true. Compass bearing of the hook head light given to us in the question is also 296 degrees compass. Therefore, the compass error becomes nil or 0 degrees. If variation is 3 degrees west, then the deviation must be 3 degrees east, making the compass error 0 degrees.
So this one is also clear, beta?
Yes, sir.
Okay, these are very, very basic calculations, but still we are just going through them so that everything is refreshed in the mind. So this is
सर
the
अपना क्वेश्चन दिखा देना सर.
question. Okay, all right. Just give me a minute. This is the one, beta.
Okay, sir.
Okay, so this was the concept of opposite peering. So let's move ahead now. The next concept which we have is position lines by sector boundaries of sector lights.
PL by sector boundaries of sector lights. Sector lights are the lights that are visible in different colors over different arcs of visibility. In some cases, the sectors may be for arc of visibility and arc of obscurement, the arc in which the light may not be visible at all. The boundaries of the sectors of the arcs of different colors or arcs of visibility and obscurement are printed on the chart. When vessel observes the change taking place from one sector to another, means the vessel is on the sector boundary. The sector boundary is then the position line of the observer.
Anything which is not clear up to here, beta? Okay, all right. Let's see it on the chart.
Let us understand the sector boundaries as PL through this example of Bellinacoti light, which is a sector light visible in different colors over different sectors. In the chart, here is Bellinacoti light, and you can see that there are certain sector boundaries which are already printed on the chart. And this light is visible in different sectors, in different colors. It's visible in white out here, red in this sector, white in this sector, and green in this sector. Now, if there is a vessel which is on a northeasterly course, observes Bellinacoti light to change as follows. 2000 hours, it changes from white to red. 2020, it changes from red to white. And at 2050, it changes from white to green. Please remember, these change in colors have to be seen together with the course that the vessel is steering. In this case, the vessel is steering northeasterly course. We need to identify of all these, which are the PLs at 2000 hours, 2020, and 2050. As you can see, when on northeasterly course, when the vessel crosses this PL, this sector boundary, the color would change from white to red. On this sector boundary, it would change from red to white. And on this sector boundary, it will change from white to green. So this would be 2000 RPL, this would be 2020 PL, and this would be 2050 PL.
So this is also clear, beta? Any doubts up to here?
No, sir.
Okay, let me show you this light actually on the chart. How does this look like? We can zoom in and see it clearly. Just give me 1 minute, I'll open it up. Okay, I hope you can see the chart on the screen, beta.
Yes.
Yes, sir.
This is, as you can see, chart number 5048, Old Head of Kinsale to Tusker Rock. So on this chart, let us identify this Bellina Koti light. Bellina Koti light is here. This is the one which we are talking about, beta. This is the Bellina Koti light. Now, if you look at this light carefully, you will see there are some dotted line associated with this particular lighthouse, and you can see this is the white sector of the light. Then you can see the red sector here. This is the red sector. Again, this is the white sector, and this one is the green sector. So it is represented by these alphabet W, R, W, G. And you can see these sector boundaries are also represented by dotted lines. This is the first sector boundary. This is the second one. Then you have the third one. And this is the fourth one. So are you able to see this, beta?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, right. So this is what we call as sector boundaries. When you approach toward this light, depending upon what is the position of the ship, this light is going to appear in different colors. So this is the meaning of the sector light. Now, if you noticed, they also mentioned about the sectors which are obscured and visible. So some of the lights, it is possible it may not be visible in a particular sector. So just to give you an example, if you concentrate on this particular light here, this is the mine headlight. Now let's go to mine head. If you look carefully, beta, you will see there is a sector which is mentioned on this side for this particular light, and this is the obscured sector. I hope the text is readable, beta.
Yes,
Yes,
sir.
sir.
Right. So this is the obscured sector. That means if there's any ship in this particular area, they will not be able to see this light. This light will not be visible. And if you go on the other side, again, you will see this is the obscured sector. This is the obscured sector. And all around on this particular sector, the light is visible.
सर उसका यूज क्या है जो obscured है? Only for the practical purpose or in the paper as well?
Okay. Practical के लिए तो बेटा it is very much useful to us because we know when we are in this particular
Yes.
zone the light will not be visible to us. So that's important information. In fact, if you are here and this light is obscured, then you are about to run in danger somewhere. So as far as exams is concerned, yes, this also can be used in some of the questions. How they can use it? They can make a question that a vessel was in this particular position. Let us say they give you a fix. Let me erase the other things. Let us say they give you a fix here that the vessel was here at 2000 hours and the vessel was proceeding on a northwesterly course, and the course is not known to us, and they tell us at 2040 this particular light, the mine headlight, disappeared. Okay, so you know at 2040 you have to be somewhere on this line because this is where the obscured sector starts. Right,
Sir,
beta?
we will be on that line or beyond that line, sir,
We will
when
be
it will
that line.
obscure.
Beta. So at the instant when this lighthouse disappears, you are on this line. So if it disappears at 2040, then at 2040 you are somewhere on this particular line. After 2040 you will be going inside it, but at 2040 when the light disappeared, you have to be on this particular line.
Okay, sir.
Okay, so this also can be used in some of the questions to provide you with a PL, position line. Okay, beta, understood?
Yes, sir.
Thank you.
Okay, great. Let's get back to the video. So we have seen these sector lights, sector boundaries. Let's move on to a position line now, which is not a straight PL. That is a depth contour PL. Just give me 1 minute.
PL by depth contour. Depth contours are the lines drawn on chart joining positions having same depth of the seabed. Depth on chart are called as charted depths. Charted depths are given with respect to chart datum, which is usually the lowest astronomical tide level. Observed depth must be reduced or converted with respect to chart datum before they can be compared with charted depths. A conversion, the tidal variance with respect to the chart datum must be allowed to the observed depth.
Beta, anything which is not clear up to here? Okay, great. Let's continue now with this information, what you are seeing right now. Using this information, we will be able to solve the next example on chart, which we are going to see now.
Let's look at it through an example. At 1400 hours, a vessel drawing 7 meters records underkeel clearance or UKC of 45 meter by echo sounder. If the tide was 2 meters above the chart datum, calculate the charted depth at that particular time. Identify on the chart at that moment if vessel could be on a depth contour.
So beta, this is the question which we have. Read it carefully and try if you can find out what will be the charted depth.
Sir, 50 meter.
50
Very good.
meters, sir.
Very good, beta. Very good. The charted depth should be 50 meters. because you see the vessel has a draft of 7 meters, the UKC is 45 meters. So this tells us that the total depth of water in that area at that position would be 45 plus 7, which comes to 52 meters. Now they have given us that the tide is 2 meters. So if 52 meters is the observed depth, the tide is 2 meters above the chart datum. We know the charted depth has to be 50 meters. 52 minus 2, that gives the charted depth as 50 meters. So basically it tells us that at 1400 hours, our vessel should be at a place where the charted depth of water is 50 meters. Now, if you have a look at the chart, you will see the 50 meters depth contour. This is the 50 meters depth contour. So vessel has to be somewhere on this 50 meter depth contour at 1400 hours. So this depth contour becomes our position line. Even though it is not a straight line, we still call it as a PL.
So first and foremost, we convert the given depth to charted depth. UKC 45 meters, draft 7 meters. This gives us an observed depth of 52 meters at that point of time. Tide 2 meters above chart datum. So the charted depth at that time is 50 meters. Now, if you see on the chart, this depth contour on the chart is depth contour for 50 meters. This is the 50 meter depth contour. So if the charted depth at that time was 50 meters, that means the vessel is somewhere on this yellow highlighted depth contour, and this depth contour now acts as a PL.
So this is also clear, beta. Any doubts you can ask me.
सर जो आपने सेक्टर वाला बताया था वो सेक्टर लाइट का,
Right, beta.
PL be that time when we are entering one sector from another sector, huh, sir?
Yes, beta, that's right. When they tell you that the light changed from white to green. Okay, so at that particular time, you will be on the sector boundary.
Yes.
Okay, great. So this is the PL by a depth contour, not a straight position line, but still falls under the category of position line. So let's proceed ahead now. Now the next what we are going to see are celestial position lines. In celestial navigation, we have done different methods with which PLs can be calculated. Marpas, long by Crone, intercept, X meridian, and Polaris. Now, many a times in chart work questions, they provide us with the information of one of these methods. So they will tell us that a observation was taken using Marpas method. This is the observed lat obtained. And then they will tell us to plot it on the chart. So how to plot the celestial PLs on the chart? We are already familiar with this. We have already done these plottings, but that was done on our answer sheet. So let us see now how they are plotted on the chart. This is basically a revision.
Celestial PLs. Celestial observations, when solved, provide a position through which to draw the PL and the direction of the PL. The position through which the PL is drawn depends on the method deployed for solving the celestial observation. The direction of the PL in every case of celestial position line is perpendicular to the azimuth of the celestial body. In case of latitude by meridian altitude, the azimuth can be either north or south. Thus, in case of latitude by meridian altitude, the direction of the PL, which is like any other case perpendicular to azimuth, is specifically east-west. Celestial PLs are represented on chart by single arrows at each of its ends.
So we are familiar with all these points. Let us now see plotting them on the chart.
Now let's look at the various methods of solving the sides, and based on each method, the position through which to draw the PL. In latitude by meridian altitude cases, the position through which to draw the PL is observed latitude and DR longitude. Direction of the PL is perpendicular to azimuth, and in this case, specifically east-west. Longitude by chronometer, position through which to draw the PL is DR lat, observed long. Direction of the PL perpendicular to azimuth. X-meridian method, position through which to draw the PL, observed lat, DR long, and direction is perpendicular to azimuth. Polaris or the pole star, observed lat, DR long, perpendicular to azimuth. And lastly, intercept method, we draw it through a point called as ITP, intercept terminus point, and the direction is perpendicular to azimuth.
So beta, this table gives you a summary of the reference points as well as the direction of the PLs in all the 5 different methods which we used in celestial navigation. So this is a quick reference.
We'll try and understand all this through 2-3 simple examples. DR position 51 degrees 34 minutes north, 008 degrees 02 minutes west. Above DR position used for solving various celestial observations. Based on the results provided, we need to identify the method used for solving the observation and then accordingly draw the PL on the chart. The first case is star X observation gave observed long of 008 degrees 10 minutes west, azimuth 070 degrees true. In such cases where observed longitude is the result, such observations are solved by longitude by chronometer. In long by chron method, the PL is drawn through DR lat and observed long. You can see here, this is the DR lat. This one is the observed long. This one is the DR long. So it is where the DR lat intersects the observed long. Through this point, we draw the PL. Direction of the PL is perpendicular to azimuth. So if azimuth is 070 degrees true, we add 90 to it and subtract 90 to get the direction of PL as 160 degrees to 340 degrees true. And this blue line then with single arrow at each end becomes the PL for star X. Let's look at the next example.
So this long by chron is clear beta, plotting of the PL.
Yes, sir.
Yes.
Okay, all right. Let's move on to intercept.
Star Y observation gave an intercept of 2 miles towards azimuth 040 degrees true. When intercept is obtained as output of a celestial observation, the observation then has been solved by intercept method. In intercept method, the PL is drawn through ITP. Now in this case, azimuth is 040, intercept is towards DR position is here. So here is what we draw the DR on the chart. Then we draw the azimuth of the body, which in this case is 040.
काफी बदखलाक हूँ इस मामले में। उनके सामने भी रोजेगा बट अच्छा नहीं लगता, वो बेचारे परेशान हो जाते हैं, और परेशान के अलावा उनका जो आई डोंट नो जो दुख होता है तो वो मुझे बड़ा ऑड लगता है कि मैं ऐसा रो रहा हूँ, मुझे कभी कभी डर लगता है आजकल।
Let him enjoy, beta.
सर थोड़ा पहले से शुरू कर दीजिए थोड़ा।
Yeah, beta. That's right. I am doing that.
Four zero. Intercept is 2 miles towards. DR position is here. So here is what we draw the DR on the chart. Then we draw the azimuth of the body, which in this case is 040 degrees true. Now intercept is 2 miles towards. Towards means from DR towards the body. So from DR we mark off at point 2 miles away on the azimuth line. And this is the ITP. This point is the ITP. Through this point, we draw a PL perpendicular to azimuth. So azimuth was 040. So PL direction becomes 130 to 310. And this segment represented by the black line here, this represents the intercept towards of 2 miles.
So this is the intercept plot, beta. Let me know in case any doubt is there in any of the items.
कुछ नहीं, जो जैसे कॉपी में करते थे वो बस चार्ट पे लगाना है एक तरीके से।
Exactly, beta. It is in fact simpler than what you were doing in the notebook. Simpler because scale कोई tension नहीं है यहाँ पे. The scale is already there. You can measure the distances very easily. So azimuth बनाना भी आसान है. You have the compass rose and the parallel ruler with you. So notebook पे हमें 360 degree round या D को use करना पड़ता था. So in fact it is very quickly plotted on the chart as compared to the notebook. Okay, so let's see another intercept example.
Now let's have a look at the last example. Star Z observation gave an intercept of 3 miles away. Azimuth 130 degrees true. This is the DR position. Azimuth is 130 degrees true. Now intercept is away from the body. So from DR, it is not towards the body, it is away from the body in the opposite direction. So we extend this azimuth line in the opposite direction. Mark of a point from DR on this line 3 miles off. This point is the ITP. This represents 3 miles of away intercept. Through ITP, we draw the PL perpendicular to azimuth. And if azimuth is 130 degrees true, direction of the PL automatically becomes 040 to 220 degrees true. So through these couple of examples, I hope it's clear to us.
So this is another intercept example beta where the intercept was away. So same way it has been plotted. You mark off the DR position, you go away from the body, the same distance as the intercept. That gives you the ITP and you can draw the PL perpendicular to the azimuth. So many of the chart work questions, they have these positions given to you by way of the celestial PLs. So you may need to plot and draw these celestial position lines on the chart. So this brings us to the end of the position line methods. We have seen different methods with the help of which position lines can be given to us in the chart work questions. And we have also seen how do we plot these PLs in all the cases. So that completes the PL topic. So any doubt, any queries, anything in your mind regarding PLs, you can ask me. All clear, beta? Done?
Yes, sir.
Okay, great.